OEM or own, the intellectual property for the only application that delivers 21st-century Cures Act and FHIR interoperability solutions in weeks, versus years. No visible competition in the multi-billion-dollar healthcare sector. The vast majority of healthcare providers and technology vendors are years away from Cures Act compliance and will miss the upcoming deadlines for FHIR regulations. First, we are seeing an empty FHIR repository that BDR-COMPLY automates the population of from HL7 messages. Here we are showing the raw HL7 messages to be migrated into a FHIR repository. We are now setting up the source, in this case HL7, and the target, in this case a MySQL FHIR repository that will map accordingly with the HL7.org mappings and migrate the selected HL7 into the selected FHIR repository. With the migration from HL7 to FHIR completed, we are viewing a couple of the populated tables. In the second table we not only see it is populated, the blob column is populated from the HL7 messages, and BDR-COMPLY securely encrypted this data as it does with all data. Additionally, we are showing the string table, an important table of FHIR, and again we see that BDR-COMPLY has encrypted this data. We are now configuring the BDR-COMPLY reporting of the HL7 to FHIR already migrated into FHIR. We selected the FHIR repository to report on. This report is downloadable by the patient or healthcare personnel. The patient or healthcare or analytics personnel select the resources and columns within the resources they desire to report on, download or migrate to SQL or NoSQL database, as you will soon see. Another important point is the BDR-COMPLY search of columns saves a lot of time, as there are well over 30,000 columns in FHIR 4 and over 40,000 in FHIR 5. The users can also search for the resources as well as the columns within the resources they wish to view, download or migrate. They simply select the checkboxes of the columns they desire and when done click on the Run icon and await their report. With the process complete, we now open the report with the Open icon. Here we are viewing the report with the columns the user selected. Once satisfied with the report results, we will next download this report. As we select the download icon to create and move a copy to the user's location, we are prompted to use a two-factor authentication for security and compliance. Next, BDR-COMPLY create another security measure by creating an encrypted key to be used in the transport of sensitive PHI. Now with the securely download report file, we just click on the CSV application to open and view the same report we saw on the BDR-COMPLY graphical interface. Here we see there are 5 tables in the Snowflake database. After we migrate the current report data, there will be a 6th. Next, we are configuring the FHIR data migration process to take the recently selected data for the report and establishing where we want the migration process to write this data to. In this example, we are writing this data to the previously viewed Snowflake repository. We are now viewing the report data we migrated into the Snowflake repository. You see it is encrypted. BDR-COMPLY securely encrypted this data. Even if Snowflake encrypts this data, users will have to use BDR's decryption process to view the data. This is an extra layer of protection. Now we are viewing an RDBMS database that we will remarkedly map process and migrate into a FHIR repository. BRD-COMPLY feels no one else has this capability without creating errored FHIR repositories. As we showed during the HL7 to FHIR process, we are showing another empty FHIR repository prior to running this RDBMS to FHIR process. We are selecting the database to FHIR process bar. We are next populating the source RDBMS and the FHIR repository information for the configuration process. Next, we select the table and the columns to be used in the RDBMS to FHIR process. By selecting the More option, we see a list of tables used for selecting a reference key. This key is used to map multiple tables in the RDBMS together to get the proper data into the FHIR repository. BDR feels they are the only company with such ability. BDR also has the capability to take data from the joining tables. We then select the next icon. We now enter in the FHIR bundle name and configuration information that will be used in the RDBMS to FHIR process. We then select the Run process and will soon see the FHIR repository populated from a healthcare RDBMS database. We will now view the FHIR repository that we populated with the RDBMS to FHIR process. As we view the new FHIR repository, we see the tables are populated as well as the data in the blob column, and we see the blob data as all data is securely encrypted as it contains PHI. FHIR users must remember that HL7 did not build an encryption capability into FHIR repositories. If you have the need to meet the 21st Century Cures Act directly from an RDBMS healthcare source versus an FHIR repository, BDR-COMPLY can deliver this. Watch as we configure the RDBMS input source as well as the selection of the tables and columns to be reported on and selected by the patient or user. Then run the process and view the results. As you saw earlier, all reporting results can be downloaded to the patient or user as well as migrated to most any RDBMS or NoSQL database or data warehouses. Lastly, we will demonstrate HL7 messages being migrated into a FHIR repository. Here is the HL7 input. Next, we configure the HL7 source information along with the FHIR repository to be populated. Once this is completed, we will run the HL7 to FHIR process. Before we start the mapping and final migration process, let's see what the conversion step BDR-COMPLY delivers from the originating HL7 messages when BDR-COMPLY creates them, and as we can see, they are encrypted JSON, as again all data BDR creates that contains PHI is encrypted. Now we start the selection process from the BDR-COMPLY created and encrypted JSON data to be migrated to and ingested by the FHIR repository. Here we are selecting the resources and fields within those resources to be migrated into FHIR for the JSON data. Once the selection process is completed, the user selects the run icon to begin the process. With the process completed, we select the open icon and view and validate the reporting results. Next, we select to download the report. As seen earlier, we are prompted for a secure two-factor authentication as well as the BDR-COMPLY application creating an encrypted key to be used in the opening of the secured download CSV file. With the secured file downloaded to the patient or user simply opens and views the file they requested. To end this amazing video of an automated FHIR and Cures Act ingestion process, we are configuring the migration of this HL7 data to FHIR process into a Snowflake data warehouse and are now viewing the encrypted results. Thank you for taking the time to view this healthcare automated technology to migrate data from HL7 and RDBMS and other sources into an interoperable FHIR repository. If you would like to discuss a source code OEM or a full acquisition of this technology and in our opinion be the market leader in the 21st Century Cures Act and the FHIR interoperability sectors, please reach us at 847-440-4439. Again, thank you.